Hey everyone, John here. In today's video, I'm going to try to figure out how I should allocate my learning time when it comes to learning computer science. So if you're following my 1K to 10K challenge, you'll know that when I make a portfolio, I allocate based off of weights. So like how much percentage of my time should I allocate to one thing? How much of my percentage of my time should I allocate to another thing? Let me see if I could show you like what that looks like even. Let's see. But yeah, so for example, in here, you're looking at like an example portfolio. So in an example portfolio, you'd be like, hey, in this specific company, I'm going to weight 11.6%. In this specific company, I'm going to weight 9.4%. So in this video, I'm going to really try to figure out how do I weight my time and energy into like different aspects of computer science such that I learn the basics and I build like a good foundation for myself, but I also want to be able to do the things that I want to do, like use AI, right? I don't want to be just focusing on the fundamentals for a year and then only after a year do I go on to the hard fun things that I enjoy doing, right? Like I don't want to make this like an academic thing like I'm going through university, right? So I have to try to figure out how do I allocate my time? So do I allocate my time 100% on programming languages, which is kind of like what I've been doing right now? Or do I do maybe like 60% on programming languages, 30% on learning how APIs and services work, and then maybe 10% on the application level, things like that. So that's what I'm going to be exploring. I think my method or like my weighting strategy is going to be based around abstraction levels. So similar to like in portfolio management, you would be like, okay, how do I allocate my time, or how do I allocate my money? Maybe I weight by the market capitalization of the company. Maybe I do it based on like a fundamental weighting. Maybe I do it based off of, I don't know, like momentum weighting or like growth at a reasonable price or something like that. I think my method that I'm going to try to do is I'm going to try to do it based off of abstraction levels. So what is abstraction? Abstraction levels in computing refer to the different layers of complexity that hide the underlying implementation details, allowing developers to focus on broader concepts without worrying about the finer details of lower levels. But yeah, so what are the different levels? So at the very, very bottom, there's the hardware that executes instructions directly. For example, CPU, GPU, and memory. I think for me right now, I don't really have to go into this level of detail. Similar thing with the operating system, which manages hardware resources and provides a user-friendly environment for software applications. Like these 2 points of this, I'll probably have to consider next year when I'm more like when I'm a power user, right? Like, for example, I really know how to build a machine learning model to maximize its performance. I have to start tinkering with the operating system and the hardware level. Only then do I want to be going into like this type of thing. But yeah, so machine code assembly. I think this is what my brother was talking about when he was talking about x86 and things like that. Low-level programming instructions executed directly by the CPU. I'm not sure if I'm going to have to go to that level even, right? Because really what my thinking is next year when I'm decent, or like when I deserve to up my hardware, and I'm going to go about how I'm doing that. So I had a comment from one of my YouTube commenters or subscribers saying like, hey, maybe you should learn more, like learn a little bit differently than what I was doing before. Before I was just kind of trying to use Chatgpt, but now I actually have a structure. Like you could see like in the last week alone, like it took me like 2, 3, 4 days to start learning a bunch of different stuff. So for example, analyzing financial data with Python, building a chatbot, I'm planning to learn how to do machine learning and learn Python 3. So a lot of the last couple of days, I've been focusing on this abstraction level of programming languages. And the reason for that is just because I actually really enjoy doing it. I feel I just have a lot of fun doing it, and I think eventually I want to, like, I think I do need this. I need to know Python and C++. I don't want to be reliant on no code or low code frameworks. I want to be able to do anything I want. And the best way to be able to do anything you want is by using code. The next thing that I'm going to be focusing on is libraries and frameworks. So libraries are basically like, it's basically like a module that you can call upon that already has functions within it that you can use within your code. Frameworks are kind of like the opposite, where it kind of guides you. So you would like use the framework and it kind of guides you essentially. It's like almost the opposite of what a library is, if that makes any sense. Like, for example, I think like, maybe I'll go into that one day, but my brother James will probably drop a video on what the difference between a library and a framework is. So like I think right now, the main key for me is really getting a handle on the programming languages, because to use the libraries and frameworks effectively and the APIs effectively, I need to learn how syntax works and stuff like that, which I'm just weak at right now because I just started learning how to code. But yeah, once I get to this, I need to learn how Docker and Git work. So like I have zero version control on any of my projects. Like when I eventually start using AI and I give them autonomy, I'm going to have to eventually try to containerize things. So that'll be Docker. So for now, I think within the next 2 weeks. So I'm thinking like right now it's November the 13th. I have 2 weeks to sprint my way from programming language, libraries and frameworks, APIs and services to development and deployment tools. So like I need to really get down my Codecademy by the 30th. That way I can be like, I can be at a reasonable level to start trying the deployment piece. But yeah, so that's kind of what I'm thinking right now. So I'm thinking of allocating like almost 70 to 80% of my free time towards programming languages, libraries and frameworks, APIs and services in the next 2 weeks, just so I can master them. That way I can efficiently deploy, like focus on development and deployment tools. Once I'm get a handle on that, I'll be starting to look at AI agents and trying to make them autonomous, right? So like once I can containerize and have like different version controls, I can finally start experimenting. Hopefully I could do that by the new year. Right? So that's kind of what I'm thinking. For the rest of November, I need to really master these. In December, I need to be focused on the development and deployment tools, and then on the application level. And then I'll kind of allocate like I'll probably do like 70% of my time here, and then 30% of my time like in living in this aspect. But yeah, that's kind of what I'm thinking. So how did I come up with this? Let's go over in high level detail what the descriptions are and like what it abstracts away. So like let's say if I don't focus on these, what do I miss out on? Let me see if there's a better piece. But yeah, like I really tried to figure out like what I'm doing. Now I'm learning Docker and stuff like that. But yeah, okay, let's go up here. But yeah, these are the different abstraction levels. So hardware, again, this is the lowest layer of the stack. It includes physical components like processors, memory, storage, and other hardware. Right now, if you watch my how to run LLM on my PC, for sure you could tell that the CPU, the GPU makes a big difference on the type of model that you can execute or you can run on your machine. Like my machine is limited to the last generation of LLMs, so pretty much like ChatGPT 3 with maybe like 8 billion parameters max with a 4 gigabyte size. That's the maximum I can run effectively on my machine. So at this level, there's no abstraction yet. It's the raw hardware that directly executes instructions. To interact with hardware without needing to understand every transistor and circuit, higher level software provides layers of abstraction. So what's the next piece after hardware? So the OS, the operating system, manages hardware resources and provides services for application software. So the three main ones, Windows, Linux, and Mac OS. My next machine, I'm planning to go to Mac OS. Please comment in the description to tell me like what I should be buying, but really I'm going to be buying Mac OS because my friend Isaac loves Mac OS. So I'm gonna do whatever he does. And then also I'm switching to VS Code just because of that guy. But yeah, I'm saving $10 a day, so eventually, like probably by September, October next year, I'll have about $3,000 to $4,000 that I'm gonna just spend on like a new PC, and hopefully by then I can really max out my current computer and just like cook it using machine learning, make it obsolete by cooking it, and then buy new hardware. But that's what my plan is. Abstraction. So the OS abstracts away the complexities of hardware management. It provides a consistent interface for programs to interact with hardware without needing to manage it directly. Perfect, right? Machine code or assembly language. Machine code consists of binary instructions that the CPU executes directly. Assembly language is a low-level, human-readable representation of these instructions. Assembly and machine code sits just above the hardware. They provide a thin abstraction over the raw binary instructions, making it slightly easier for humans to read and write code that the machine understands directly. So I don't know how far I have to go within this level. I think really like the OS and the machine code piece, I could probably just like ignore for a while, and then the hardware piece I'm gonna have to focus on when the time comes. Like I'll know when my system is limiting me for sure. Like it's like obvious when your system is limiting you, but I bet there's other solutions. Like I go to cloud compute instead. Programming language. So these are higher level languages like Python, C++, Java, JavaScript that are easier for humans to write and understand. So right now I'm just focusing on Python specifically because I'm focused on AI. I don't really need C++, Java, and JavaScript. Like Python has good libraries, and I'll go into like what the libraries are, but there's like TensorFlow, PyTorch, all like the different tools. It actually doesn't go into that, but yeah. Programming languages abstract away low-level details, allowing developers to focus on logic rather than specific CPU instructions. The compiler or interpreter handles translations to machine code. So that's pretty cool. But yeah, like before I did this, I was like, what's an interpreter? What's a compiler? I didn't really know. Turns out it just makes it into machine code, and the machine code talks to the hardware. That's kind of insane, right? Like me as a non-techie background, like a finance background, I really appreciate like the computer science aspect. But yeah, APIs, so application programming interfaces. So this is something that's new to me. Before, when I was new to YouTube, you'll notice that most of my YouTube channels were within, or like my YouTube content was within the Chatgpt 4.0 UI. But now I'm really heavy in the coding and then calling the API instead, just because I have much more control over my prompt as well as the output of the prompt, and then I can easily gauge whether my prompt is improving or not, right? It's easier for me to evaluate my conversations with ChatGPT if I have like an API, if I'm interfacing with the API rather than with the UI. But yeah, the APIs abstract the complexity of interacting with external systems. Instead of handling the internal workings, developers use predefined methods or endpoints. So like you're basically connecting with like an external software. Development or deployment tools. So yeah, like like I said, most of my current time spent is programming languages, libraries, and APIs. Right, I'm learning about the Y Finance API. I'm learning about the Math API. I'm learning about the OpenAI API, the Google Gemini API, like a bunch of different APIs. Whoa, ad block, interesting. But yeah, like a bunch of different APIs. But now, like I'm slowly, I'm gonna slowly learn how to use like GitHub, Docker, and then like other pipelines. And I'll be working on projects with my brother and friend to like learn these deployment tools, because I don't think I can learn them on my own. Like I'd rather learn through job shadowing type of thing. But yeah, these tools abstract away software development and deployment, making it easier to manage code, automate testing, and deploy applications without dealing with underlying infrastructure manually. And then the application level. So this is the level where end user application exists, such as web browsers, email clients, and business software. At this level, the complexity of lower levels is entirely hidden. Users interact with a graphical interface or API, oblivious to the underlying hardware, OS, and code execution. So this is where most people live. I'm trying to kind of like go into it a little bit more, and then again, like when I need it, I'm going to hit like the hardware. I'm going to hit the OS. I'm going to hit the machine code assembly. But yeah, that's the initial stack. So right now I'm going to be overweight these three API library programming for the next month. I mean, like the next two weeks, 3 days. Like I'm gonna sprint my way through this. That way I can start like really actually contributing to like me and my brothers and my friends' projects. Because otherwise, like they're teaching me stuff that I should just know on my own, right? Like I don't want to be disrespectful or anything with their time. But yeah, that's kind of like what I'm thinking. But yeah, so that's kind of the process. It kind of went over, like I tried to see, like give me a deep dive on each design and design a report to help me allocate my study time. But really, like I'm going to ignore it. It's saying 10% to hardware. Like I already know that I'm gonna focus on that when the time comes. The OS, I'm gonna focus on that when the time comes. The machine code, I'll focus on that for sure when the time comes. But yeah, the programming languages, allocate 20%. Libraries and frameworks, allocate 25%, and then APIs, allocate 15%. And then like the GitHub and stuff like that, I'm gonna just learn from them. But yeah, I hope that makes sense. Right? Like I'm really trying to figure out how to weight my time, because like I know that I weight my time. Like I think of everything like in the context of opportunity cost, right? So like I don't want to be overweight 100% in like a stock. Why would I be overweight 100% in like one of these when tech moves so fast that like programming languages might become obsolete or like be not required in the near future? Like I'm not sure if you've ever experienced using GitHub Copilot, but that thing is insane. It's insane. But yeah, for now, I'm going to try to avoid that. But once I have a comfortability, like probably within the next, like I'm going to try to avoid all of that, like all of the powerful tools for now, and just work with my hands and get my feet wet. But yeah, like once December 1st hit, the brakes are off. I'm going full augmented coding abilities, like GitHub Copilot. I'm paying for it. Um, Everything I'm paying for it, and then I'm just gonna I'm gonna like really be slow for these couple of weeks and then go full steam ahead in December. I don't want to go full steam ahead just yet. The reason why is because I need to know the fundamentals at least a little bit, right? So even when the time comes and I have ability to use GitHub Copilot and all that stuff, I'll probably try to like limit it maybe like 3 to 4 days a week so I could still like have the basics down. But being able to really like dial these in and then use GitHub Copilot to like master these will allow me to allocate my time more towards like other aspects. But right now I think like these are the major keys for me. But yeah, please like and subscribe and follow my growth. I'm really enjoying my comments lately. This one's a funny one. What is your end goal? Don't you already have a job? I don't even know what my end goal is. I'm just trying to I just enjoy this stuff. Like I can't stop. I really can't stop. But yeah, you're welcome, Jimmy. The roadmap helps me a lot too. And then my brother and my girlfriends are are in here. But yeah. I hope this helped. Please like and subscribe. Until next time. Bye.